pleasure to be here. I've had a long career in science, and over the years I've always been astonished at the scientific discoveries that come our way that I would call good luck. That's what all scientists hope to have. None of us want bad luck, but we all want good luck, and that amounts to surprises. And that's what I want to talk about tonight. I was 4 months on the job in Salt Lake City as new state paleontologist in 1988 when I got a phone call. I had moved there from New Mexico, and I was still learning about the geography in the state. The phone call came from a man with a burly voice and a little bit of edge in his tone to tell me that he and others had discovered a dinosaur bone. Well, that's not too uncommon for us to get phone calls like that, but he said he had lifted the dinosaur bone and put it on the bank, and it was at a construction site. And he was worried that that was going to shut down the construction activity because of state laws and requirements established by the Forest Service. This was on 8/8/88. That was August 8th, 1988. It was an auspicious day. He explained to me what he had and said he was working at a repair for a dam at high elevation in the Wasatch Mountains, not far from Salt Lake City, but at much higher elevation. And he wanted me to come look at this dinosaur bone in Huntington Canyon. Well, I resisted the urge to ask him, where is Huntington Canyon? I was new on the job, and I didn't know where it was, but I didn't want to admit that. And we agreed that I would, as soon as I could get a vehicle, I would visit him and the construction site and see if we could check out this dinosaur bone. And it turned out that this was an amazing experience, and I would call it serendipity. It was a step above good luck. Everything just fell into place. 2 hours later, I was on site, and he showed me the the humerus that had come out of the ground, and I realized that it wasn't a dinosaur, but instead was from another animal. And there was also a very large rib that had been pulled from the dam construction site. That rib was broken and had been laid on the side to dry out. This is what the site looks like today, and it shows where the excavation occurred at the base of this dam. The dam had been built in the 1930s on a bog base. The construction crews did not clear the bog to ground rock, or to the bedrock, and instead built this dam out of earthen materials and backed up water that had been used in the ensuing years for irrigation, for farming at low elevation in the valleys nearby. So this site was at 9,000 feet in the Wasatch Plateau, and this is what the construction site looked like when I got there. There were dozens of large, heavy equipment, machinery, probably 30 construction workers on the site, and it was clear that they were urgent because this was August, and in the Wasatch Plateau at high elevation, winter sets in as early as September. So they were urgent to keep the repair work going, and they wanted me to tell them that it was okay, they could keep working, and they wouldn't have to stop. I realized when I got there that it was not going to be a dinosaur excavation or a dinosaur discovery, but instead it was going to be a discovery of probably one of the animals that lived during the Ice Age, about between 2 million and 10,000 years ago, when much of high elevation Utah was under glacial ice. Part of the glacial episode at the end of the Ice Age had continental glaciers extending as far south as Ohio and Indiana and Missouri, and extensive glacial development in high elevation mountains, including in our own San Francisco peaks. So this was clearly a glacial situation, and that rib turned out to be key to what we had developed over the course of the research project that developed. Serendipity, to me, is something better than good luck. It's, in science, finding something when we're looking for something else. It's a surprise. This is what we all dream of. We always hope it's a good surprise. And I had realized that the bone that they had put on the hillside, the leg bone and the rib, belonged to an elephant. But I wasn't sure which elephant it was. Mastodons had been known from this area, from fragmentary recoveries at this elevation, but nobody had found really good material, so even a mastodon would be exciting, and that's what we expected it would be, because mastodons lived in high elevations up to as much as 10,000 feet. They were browsers and fed on trees and bushes, and they were much more agile than mammoths that lived in lower elevations and fed on grasses and usually in open grasslands. But until we could find more evidence, I couldn't tell from those bones whether it was a mammoth or a mastodon, and if it was going to be a mammoth, would it be a Columbian mammoth or a woolly mammoth? Well, it didn't take long for that question to get settled, because we found in the first day jaws and teeth from our dinosaur, which is now not a dinosaur, but instead an elephant, and ours showed the teeth of a mammoth, not a mastodon. Here you can see the difference between the teeth of these two very large elephants. The mammoth has a series of plates that get worn into a washboard while they're feeding on mainly grasses. Mastodons had more of a crunching dentition, and their teeth did not wear down into flat plates like we have in mammoths. Here's the excavation on the first day after discovery. The construction crew, when they realized we had a mammoth, threw themselves into this project like nothing they'd ever done before. So we had lots of bib overalls working on the project, lots of hard hats, and then we had lots of volunteers from Salt Lake City and also Price, Utah, which was just over the mountain and close by. And we set into our excavation and got down to the bone level and found the skull right away. We'll see that in a moment. And then realized that all these bones were in sloppy bog. And it was an absolute mess. And as we were trying to scrape away the bog sediments and mud, we could look at the wall behind us where they had been removing bog sediments at the base of this dam. And because they had removed sediments to our level, those sediments in that wall were moving toward us. So it's clear we couldn't take 2 or 3 months to do an excavation like I would like, but instead we had to move fast. And we mobilized an amazing crew of people who had no experience at all, but had lots of ideas and really loved working in the mud and working with us in a site like this. So the Huntington Dam is behind them in this photograph, and they're working in mud. This is the mud as it developed. It was dried at this time of this photograph, but we had scooped out lots of wet, sloppy mud. And that large object in the middle of the photograph that's white is the skull that we had to encase in plaster to protect it. But all of the other bones were so well preserved that we could just lift them out of this muck. The bones were like what we would expect bones to be if they were kept in our refrigerator for a couple of months. They were that fresh. They were a little stinky because of the bog, and we thought maybe we would even find meat with the bones. They were that fresh. This is what the bones looked like when we first exposed them in these boggy sediments. Those are 2 femurs in the one photograph and then a string of vertebrae in the other. So most of the skeleton was there. We recovered about 95% of the skeleton. You can see the layout for the bones as we took a photograph and strung string in a grid pattern so we could make a map. We took those photographs from that bucket in the upper right. You can see it in the upper right part of the photograph. So we had gained the trust of the construction workers to the point where they would work with us, and we asked to go up in the bucket, and they said, sure, let's do that. I'm sure OSHA would complain about that today. This was back in 1988. So that's the layout for the skeleton. It turns out it was all there except for the other humerus. A part of the tusks had been lost, and one of the tongs in the bucket for the lift had snagged one of the cheekbones for the skull and had broken it away, and we lost that. We never did find that. Probably had snagged it before they realized there were bones in the bog. You'll see that in a moment. So here are labels for all those bones. The skull was exceptionally large, and we were worried that it would fall apart and crack if we didn't encase it in plaster and burlap. So we did that. We had to keep all of the bones wet because that rib had twisted, that broken rib that was on the bank had twisted like a pretzel. And that indicated to us that collagen was still in the bone. Collagen is the flexible part of bone, the protein that makes bones flexible and allows ribs to expand. Other ribs that we took out, we could hold above our heads, and we could bend them, and they would spring back. I had never seen that in any kind of fossil. Fossils are almost always brittle instead. So we realized that fast drying would mean that the bones would crack and split. So we had to keep them wet as we excavated. So we had people who were assigned the responsibility of scooping water out of the bog and keeping all the bones wet as we worked. And then we wrapped them in wet burlap and then in plastic as we took them back to the labs. And then in the labs, it took a long time for them to dry out. Here are broken ends of tusk fragments that came out of the ground with the mammoth. We were disappointed not to get complete tusks, but enough is known about Columbian mammoths, which is what I had determined its identity to be, that we could reconstruct those tusks in displays. This is an artist's interpretation of a Columbian mammoth. It's different from the woolly mammoth because it's much larger, and the Columbian mammoths lived in the southern part of the United States and Mexico, and the woolly mammoth lived much farther north, and it was much smaller. Later study indicated that this was the largest mammoth ever excavated. And there have been literally thousands excavated across the northern hemisphere in Asia and North America. It was a 65-year-old male, had bad arthritis, and he was probably solitary in his movements as he had wandered up Huntington Canyon, probably looking for food, and eventually fell into that bog and died. This is a mounted skeleton showing the skull with the teeth. You can see those teeth are diagnostic. This is the Huntington Mammoth from one angle, and here's the Huntington Mammoth skull. On the left is the palate part of the skull. You're looking at the skull without the lower jaws. And you're looking at two teeth and then the palate, and you can see the tusks attachment for where the alveolus for the tusk at the front of the skull. You can see one cheekbone is there and the other cheekbone is gone. We never did find that cheekbone. On the right is a skull showing the nasal openings right in the middle of the skull, those two semi-lunar black figures. And you can see on the back of the skull the point where muscles would attach that controlled the jaws. One really remarkable experience I had with this skull was I could put my hand into the back of the skull, the opening for the neural canal at the occiput. I could put my hand by squeezing it a little bit inside that opening, and then I could feel the folds and crevices of the brain cavity. It was almost like communing with an ancient animal. It really left a lasting impression on me, not something I'd never experienced. So that's the skull. The rest of the skeleton was really incredible. It was preserved as ebony-colored bone, black bone, or light black bone, kind of grayish. This is a cast of the skeleton. The original skeleton is in a museum in Price, Utah, and kept under strict humidity and temperature conditions. But it's been cast and sent to museums all over the world. Farthest I know of is Japan. I think it's been cast maybe a dozen times and used for display as one of the most pristine and perfectly preserved skeletons ever recovered. So this was Serendipity. 1988, it was a very large project. It had a lot of publicity. We managed to do a lot of education with the public. And there's always a lot of pleasure in seeing one of your excavations go on display and for future generations to enjoy the fruits of your labor. So this was really pleasant for us. There are lots of aspects to serendipity, but I think in all respects, serendipity is just a little bit above the ideas of good luck. That reservoir is today managed as a state park. It's called Huntington Reservoir State Park. You can find Huntington Canyon on a map of Utah. Next time you travel toward northern Utah, either on Price side or the Salt Lake City side, it's a short diversion to drive up into this habitat and see Huntington Canyon and the site where this mammoth came from. But the serendipity doesn't end there. The bones were so perfectly preserved that they preserved organic compounds in their structure. I said they contain collagen. Well, they also contain proteins from the original animal, proteins that had not been degraded. A few years ago, well, I think about 5 years ago, a team of paleontologists who specialize in paleogenomics or paleogenes sampled the Huntington Mammoth and wanted to know if they could get a complete genetic reading from mitochondrial DNA for one of the compounds that is coded with mitochondrial DNA. We call it mDNA. That mitochondrial DNA is not nuclear. It doesn't come from the nucleus of the cell, but comes from an organic, or an organelle that actually originated evolutionarily as a bacterium. So they took the sample from the Huntington Mammoth for mitochondrial DNA, and they claim that this is a hybrid of a Columbian mammoth and a woolly mammoth. I had lots of trouble identifying it, and when I called it a Columbian mammoth, part of the argument was that we were in the range of Columbian mammoths and out of the range of more northern woolly mammoths. There were also some other characters that were more like woolly mammoths, but they were not as convincing as the characters in the skeleton that would indicate Columbian mammoth, including the size. The size was extraordinary. So this mammoth turns out to be maybe a first-generation hybrid. So the two populations had overlapped, and we got mixing of the population and an individual that really defied identification. And to this day, it's hard to call it one or the other. The genes indicate woolly mammoth. The morphology or the shapes of the bones indicate Columbian mammoth. So this is the serendipitous story that keeps on giving. Here we see a comparison of the size of woolly mammoths and Columbian mammoths. Woolly mammoths lived in the northern part of North America and Columbian mammoths in the southern part of North America. This slide doesn't show the area where they actually overlapped, but maybe they overlapped because of the high elevation at 9,000 feet. This was the highest at the time in elevation that mammoths had ever been discovered. They're otherwise known from lower elevation in the prairies and plains and not in high elevation. Since our discovery, several others have been recorded, including one at 10,000 feet in Colorado. So they beat our record. So serendipity, this is a classic story for me of good luck that just kept on happening. There are lots of tangential stories that go with this discovery as well. And it's a discovery that I keep working on, and I'm always glad when other scientists can work on it too. So this was the unexpected discovery that keeps on giving. That's the role of serendipity in science, and I think we all benefit from that. We all can be ready for serendipity, but we can never predict when it's going to happen. You never know when you're going to get a phone call unless it's on 8888. Thank you.